Guys, today I'm going to do another question from 2.7. So we're going to go through question 2, and this is one about a girl skipping, and they give us a graph for one cycle of her jumping. So we've got to find the equation of that graph there. So the height is in millimeters and the time is in seconds. So let's think about what our usual parent graph looks like for cos. So y equals cos x. So that would just be like this, going from 1 to -1. And of course, the period of a cos graph would be 2 pi. So that would be y equals cos x. And we can see that a few things have happened to change that graph into what's given to us and what we're trying to find the equation for. So the first thing I'll do is say, well, we've flipped it over. So you can see that because we flipped it over, it's going to be negative cos x. So it's changed to that. The next thing I would do is to look at these values here. And we can see that now instead of going from -1 to 1, it's actually going from 0 to 100. So, well, in that case, the graph, the center of the graph, or the average value there would be 50. And that means that from 0, it's gone up by 50. So we've added 50 here. So by going from 0 up to 50, so the average of the top graph is 50, and the average of our parent graph would be 0. So we plus 50 to get there. The next thing we can see is that, well, the amplitude is going to be different. So we go here 0 to 1, but now it's going 50 to 100 and 50 to 0. So this must be a 50 as the amplitude as well. So I'm going to put that in. So we're going to have negative 50 cos x plus 50. So far so good. We've found the values of A equals negative 50. We found the value of C, and the value of C is 50. And now we have to find, well, the value of n. And n is when that's related to the period. So n, 2 pi divided by n is going to give you this value here. So for one cycle. So the period is 2 pi divided by n. So we can see that the period is 1. So it takes 1 second for the girl to, do one cycle of the skipping there. So we can say 2 pi over n equals 1, and that means n equals 2 pi. So now we've got h equals negative 50 cos 2 pi and t minus 0.5 and plus c is 50. So that would be our equation there with all the values we have found. So the only one I didn't write there was n, so I'll put it on the list here. N is 2 pi. All right, so now that we've found the equation, we can answer any questions about it. So let's see what they want us to do. After how much time from the beginning of the turn is the girl's feet 40 millimeters off the ground? Give your answer correct to one decimal place. Okay, so on that graph, what we're looking at is where we are 40, where we first reach 40. So 40 must be somewhere here. And they're asking us how long to the nearest decimal place, one decimal place. So in other words, this is y equals 40. So option A, we could sketch those two graphs on CAS. We could draw the cos graph and we could draw y equals 40 and see where they intersect for the first time. So that would be one way we can do it. The other way we could do it would be to solve on CAS. So you could use your solve function. 2 pi t minus 0.5 plus 50 equals 40. And of course, I would use x here if I were you, because it's just easier to solve. You would need to put a restriction there. So it's going to be x is between 0 and 1. And what we find is that t is going to equal 0.2 seconds. All right, so that's question 2, so there's only 2 parts to that. We'll move to question 3 in this same video. So question 3, they're talking about a Ferris wheel, and again it's got a cost graph that we have to work through, and as usual I would draw that before answering the questions. So this here, some people don't like it because the 5 is, in a little bit of a different spot to where, you would usually see it. What this is 3.5 cos pi t on 30 plus 5. So no big deal, just put the 5 at the end if you like it better there. So I'm going to draw this graph, remembering that a cost graph is like this, usually, going to 1 to -1. But here we're actually doing an upside down cost graph, and we're going to be going for a start from 3.5 to -3.5 and upside down. Whoops. And then of course we're going to be going up by 5 units. So we can say -3.5 plus 5 is going to be 1.5. 1.5, and then, well, here this would be in the middle here, and we're going to be going up by 5, so that has to be 5. And 3.5 plus 5 is going to be 8.5. So it looks like this. And now the only thing we need to still do is work out the period there. So the period is 2 pi divided by whatever's in front of the x, and that's going to be 2 pi on 1 times 30 on pi. So we can cancel those, and it's going to be 60. So this is quite a usual period. You see it quite a lot, 60 seconds there, and obviously that's 1 minute. So it must mean that for the Ferris wheel to go round one full cycle, it takes 60 seconds for that to happen. So that's what the graph looks like, and I would definitely encourage you to draw that before you answer the questions. Either you could even just do it on CAS there. Just a little bit of extra practice with sketching by hand is good too. So let's see, the people can enter a chair when it is at its lowest position at the bottom of a rotation. They enter the chair from a platform. How high is the platform above the ground level? So it must be that people are entering here, so it must be 1.5 meters above the ground. So for A, 1.5 meters above ground. All right, let's have a look at B. So part B, what is the highest point reached by the chair? So we can just refer back to the graph there, and we can see the highest point reached would be 8.5 meters. And again, if you draw it first, then all these questions are pretty easy, and you've got a visual representation of the cycle of the Ferris wheel, or whatever the question would be asking, and then you can find your values quite nicely. Next, how long does one rotation of the wheel take? So we've already got that from the graph too, 60 seconds. So now that we had the graph, we could answer all those really quite quickly. The next part, I think there's one more part. Yep. During a rotation, for how long is a chair higher than 7 meters off the ground? Okay, I'm just going to redraw it down here so it's easier for us to see. And 8.5. And we had this, and there was 60 seconds. And now we're finding for how long it will be 7.5 meters off the ground. So let's find out 7 meters off the ground. So that means that we're talking about somewhere here. So on your graphs and tables, you could sketch the cost graph and you could sketch y = 7, and you would find the intersections of those two, because that will tell you when you are 7 meters off the ground. And I probably should make these open circles because it's higher than 7 meters off the ground, so we're not actually including that. So what we're trying to find is how long does it take for that part of the cycle. So once again, and we see this sort of question quite often, once again, these are the times over here. So this would be the time it starts being more than 7 meters off the ground, or when it is 7 meters off the ground, and then it's above 7 meters, still above, and when we get to there, then we are 7 meters again, and below, and furthermore from that, we go lower than 7 meters. So that's T2. So you could find those two values on CAS, or you could do it by solving on CAS. So, I mean, if you're to solve on CAS, you would use your solve function. We're equating -3.5 cos pi t on 30 plus 5 = 7. And the values I got, whether you do it on graphs and tables or in main, the values we get for T1 and T2, I'll write them here. So 20.808 317, and T2 I get 39.191683. So from the time it starts, we'll call that 0, 20.808317 seconds later, you are 7 meters in the air, and then you get higher, then you go back down a bit until at 39.191683 seconds, you're again at 7 meters above the ground. So we're trying to find out how long you are going to spend here to do this yellow part, the part I've highlighted there. So we're finding the difference between these two times. So we can do that. So the time above 7 meters is 39.191683 minus 20.808317, and that is 18.4 seconds to 1 decimal place. Right, so it's not too hard, this sort of question, but it's common. So you definitely want to know how to find the time between, because it comes up quite often. That's the end of question 3. I'll do the next ones in another video.